So we're going to continue our endeavors in polynomials today. We've got to analyze what's going on with graphs. This is a graph of a polynomial. It's specifically a even degree polynomial. There's both hands pointing down. These are things that we're going to start recognizing. We're going to be able to count the number of turns and figure out probably what degree it most likely is. But for this particular question purposes, we're just trying to figure out what's going on from D to E. Now, the things we're concerned about right now in this, just in these questions, are whether or not it is positive or negative. And what we're talking about there is if f of x is positive or negative, that means the y height. If the y height is above or below, specifically the x-axis. So if it's up here, it's positive. If it's down here, it's negative. It's really that simple. And then we're secondarily going to be looking at whether or not it has positive or negative slope. If it has positive slope, I'm going to put a positive m, it's called increasing. And if it has negative slope, it's going to be called decreasing. So all we're trying to be concerned about is whether or not the function is going up or down from left to right on our interval. Now, since we have 2 points here identified, D and E, we're just going to kind of draw a line through those. My line's not that pretty, but you go with it. And that's going to guide us with our thought process about increasing and decreasing. So we're just going to look at that line and be like, that line has negative slope. Since it has negative slope, we're going to call it decreasing. So that's one thing that we had to be concerned about. So we're going to say this is decreasing. But then the other thing we're going to be focused on is that this little segment, this snippet, is above the x-axis. That was supposed to be a box. Above the x-axis. Since it's above the x-axis, it's positive. It's a positive interval of y heights, and it's decreasing. Now, what some students are concerned about is they're going to look at this and be like, well, the x values, there's some x values that are negative, and there's some x values that are positive. That's not what we're looking at. We're looking at the y heights, whether the y heights are positive or negative. So we're going to scroll down here. We've got a few options, and we're looking for that this little segment is positive and decreasing. So that's what the question calls for. Let's do another one. Taking a look at this function, this is an odd degree function, and I know that because the arrows are pointing in opposite directions. I could tell you probably most likely this is a cubic function, but we're not concerned about that here. We're concerned about what's happening from B to C. So just focusing on from B to C. And so just like the last problem, we want our strategy to be connect the dots mentally, or actually physically if you had it on paper, and notice that this would be a positive slope line. If it's positive slope, we say that it is increasing. So it's increasing. And then the second thing that we have to be worried about is whether or not it is above or below the x-axis. And it is below the x-axis, which means that this is a negative interval that is increasing. So we come down below and we select that it is negative and increasing. Hopefully that's working straightforward for us. We're going to have some special cases coming up here. In our first special case, we're being asked to look and consider from x equals negative infinity to a. So what that's dealing with is everything left of a. So this from negative infinity to x equals a is really x is less than a, left of a. Well, what's happening there is we are stopping here, and we're tracking this arm of the function. Now, I forgot to mention this is a even polynomial, and again, we could count the terms and figure out what degree it is, but the concern is what is happening here? Well, first of all, I want to recognize this is all above the x-axis, so it's positive. It's positive on this interval. The question is what is it doing? Is it increasing or decreasing? So many of my students will say this is increasing because our eyes are drawn to that arrow and our brain says it's going up. No, we don't read a graph from right to left. We read or from bottom to up. We read the graph from left to right. You actually have to look at it from left to right. Going this way is how we have to read the graph. So pick any dot on this arm and connect it to A, and you will see that that is a negative slope line segment. Any line segment I make on this curve, this arrow moving toward the left, any segment I put on there actually has a negative slope. So the answer for this one is that it has, it's a positive interval that is decreasing. When you have negative slope, it's decreasing. Positive interval, decreasing. Let's look at another special case. Now we're going to go to the right from C to infinity. So this special case focuses from here and to that arrow. Now, less mistakes are made with this one, but still want to point it out. This interval, everything down below here are negative values. So this function is negative on the interval, and it is also, if I connected any two dots along here, it also has negative slope. Whenever you have negative slope on an interval, it is decreasing. So we say that this is negative and decreasing on this interval from C to infinity, forever to the right. It's a nice quadratic question for us. Let's take a look at one more special case. Another quadratic for us. This time we're going from negative infinity to A. And this situation is the opposite of the one that we did 2 problems ago, where we have from negative infinity and we're going to A. And so we're going this way, reading from left to right. Now, again, my students often follow the arrow, and our brain says, that's going down. Well, these are negative values. This is a negative interval, but as you read the graph from left to right, you don't follow the arrow and go further down and left. You have to start left and go right. So we pick any dot here, you can connect it right to A, and you'll see that if I actually go from left to right, I'm going up. If I track the parabola going from left to right, I move up the arm. So this is a positive slope segment, which means that this is an increasing interval. So I want to scroll down below, and I want to say that this is a negative interval that is increasing from left to right. So negative y heights, increasing slope. Well, not increasing slope, sorry. It has a positive slope, which means that it is increasing. For our last special case, what we'll find is that we have C to infinity. And this last special case here is we have positive y values. So this is a positive interval. And then this graph, track the arrow, it's moving up and to the right. The slope is positive, which means that this is an increasing interval. So we would click positive values and increasing. So those are the 4 different special cases as we go toward the endpoints. We're going to start focusing on end behavior very soon.